Hi, I'm Toshko Andreev. I'm the current president of Formula Electric at Berkeley.
Yeah, my name is Mia Galatis, and I'm the vice president of Formula Electric at Berkeley.
My name is Duncan Ritchie. I'm the chief mechanical engineer.
My name's Adrita, and I am the accumulator lead, which means the high voltage battery lead for the car.
My name is Arnav Patel. I'm the chassis lead on Formula Electric.
Hi, my name is Arundhati Parikh, and I am this year's Brakes and Ergonomics lead here at FEB.
So Formula Electric at Berkeley is a student-run engineering organization where we build like a F1 style electric race car, where we have a one-year design cycle and we compete every year in Michigan.
And so we build a car from scratch. We design, validate, test, and run the car. Of course with help from the university, but it is fully all students that do this.
Right now we're about a 150, 160 person team. When I started off, we were about a 30-person team. Sponsors are vital to our success. There's a lot that goes into making this car. A lot of money, a lot of time, a lot of effort. Then as president, I basically oversee all technical and other operations of the club. So everything from working on the design with our technical leads and trying to figure out how we can make the car faster and better, and also planning logistics for our events or working with sponsors like Fictive really help us create parts, create a car that we otherwise could not create. A car that's much faster, much more optimized.
And so Fictive is able to come in and make these parts for us, which is incredible because they're able to hit really high tolerancing, amazing finishing. Like they just do such a good job on the parts, so they're things that we don't really have to worry about. And it's also a fantastic learning experience to be able to talk with engineers at Fictive, to kind of work with them and learn about how, real life talking between like production and manufacturing and the people assembling. So my role as chief mechanical engineer is to ensure that all of the different mechanical sub-teams of the car are integrated smoothly and designed and validated with engineering first principles and according to what we want to do with the car every year.
We were downsizing our wheels from 13 inches to 10 inches right here. And then that meant repackaging the entire wheel subassembly. So working with the dynamics sub-team, the powertrain sub-team, and my own members to make sure, number one, everything could fit, but also that the brakes assembly would be strong enough to work with much smaller rotors, which is actually the parts Fictive manufactured for us.
So obviously we're a racing team, so we want to really maximize we want to optimize our car so it can drive as fast as possible. So one of the parts that Fictive made for us last year for our battery pack is these structural rails made out of a very specific polycarbonate material. And the reason we have to use this really specific, difficult to machine material is because it's actually known for its insulative properties, both thermally and electrically, which is super important in creating a safe battery pack. And then when we take those battery cells and we package it in a safe and compact way so that it saves space and it saves weight where we can, but at the same time it's really efficient and can produce the maximum amount of power for our motor.
Yeah, so I manage a team of around 6 students, and for chassis specifically, we start off by designing the main 2D master sketch of the car in SolidWorks, essentially setting all the different space claims for all the different sub-teams that you've heard about from my teammates, and making sure that they have enough space to place their components in the car and there's enough clearance from the steel tubes around those. So designing around that accumulator and making sure there's enough clearance to be safe and rule compliant is a big challenge that we were able to learn about and work around. We have to manufacture it in a way where, transitioning from CAD to real life, there aren't any clashes when we come to place the components in the car.
For example, Fictive really helps us an enormous amount with manufacturing for all of our different parts that are too complex or have too many requirements for us to be making in-house with students that don't have as much experience and time and knowledge.
And I think what we had a lot of back and forth with Samson and the rest of the Fictive team, Nicholas, etc., was really how we could optimize our design to make it the most manufacturing friendly and help us cut down on our quotes.
He helped us drop our costs for 4 of our parts by 50% this year just by changing the tolerancing up and talking to us about that. And it's things like that that are really incredible because that's what's important.
I've been on the team for 4 years and spent a lot of time working on it and working on the cars. The reason I'm still around, the reason I'm still sticking with it, and why I love this team so much is because The impact it has, I think, on our community, on the Berkeley community, on the engineers here is immeasurable.
The biggest reason that I put so much time in and the reason I want to work so hard and why I see a lot of my members working so hard too is we really want to make it through that very last barrier and cross into, the dynamic events and the rest of the competition and prove to the other colleges too what we already know, and that our car is awesome and that it's going to do really, really well.
Yeah, it's definitely really exciting. It's very stressful. A really big part of our competition is getting through inspection. So we have multiple days of judges coming by and doing different tests on our car and making sure it's safe to drive. And those are kind of the most stressful days because it's a lot of standing in line, presenting your car to the judges, and then they say, hey, this doesn't feel rule compliant. Can you maybe try and fix it?
March 22nd, we had a massive deadline. We wanted our car to run for the first time in the spring semester. And so we had this massive push from the entire team. And it's one of the most incredible things I've seen. I can't even count how many problems were solved on our mechanical systems, on our electrical systems. We were able to assemble 7 of our 7 segments for the battery, so 7 modules within that battery in one day, and then diagnose a bunch of problems with them and figure out where we can keep improving and fix some of those problems that we're seeing. We're in a tough time right now, and seeing that push, seeing that energy really come through in every person on the team was incredible.